Hi, morning guys. Today I'm going to discuss the problem that I gave you last week. Okay, we discussed question number 1. Calculate the magnitude of the force between two 2.5 coulomb point charges 3 meters apart. Okay, so that two charges will be 3 meters apart. We call this one Q1. Another one is Q2. They are the same. 2.5 coulomb, 2.5 coulomb, both positive at a distance r of 3 meters. Okay, and find the magnitude of the force. So first we label the force between them. That will be repulsive. Okay, repulsive. So they will be pointing away from each other. Here, so I'll call this one F12. This is F21. Remember the protocol we use. Now, first thing, label, done. Number 2, calculate the magnitude. So the magnitude for both will be the same. So we calculate for one only. So the formula will be K Q1 Q2 over R squared. And our value is K, you already know the value, I don't write down. And the charge is 2.50 square because it got both the same. And the distance is 3.0 square. Okay, so we get that value first. That will be 2.5 square divided by 3 square and then multiply by 8.99 10 to the power 9. Okay, we got this 6.24 10 to the power 9 newtons. Okay, so there's a force in between them. Right? But since the magnitude of 2.1 is the same as the magnitude of 1.2, so the answer is also 6.24 10 to the power 9 Newton. Alright, for both. But because the question only asks for the magnitude, so we don't give the direction. Okay, so we just leave the answer like that. So that's question number 1. Done. Okay, for question number 2, how many electrons make up a charge of negative 30 microcoulomb? That's number 2. So if you have a total charge of Q equal to negative 30.0 microcoulomb, how many number of electrons we have to contribute to that negative 30? So I need to know the charge of 1 electron. So the charge of 1 electron, normally we put as E, is equal to negative 1.602 10 to the power negative 19 coulomb. You can get this one from your calculator. Okay, from this calculator, it is E. That will be constant number 23. Okay, constant number 23. So to get a number, okay, total number of electrons, so total number of electrons is equal to the total charge Q divided by the charge of electron. So we have Q is equal to negative 30.0 microcoulomb divided by negative 1.602 10 to the power minus 19 coulomb. Be careful with this one, micro. Okay, so the micro is 10 to the power minus 6. So we have 30, 10 to the power negative 6 divided by 1.602 power negative 19. Okay, we got this answer, and the number is 1.87 10 to the power 14. Okay, this is the total number of electrons needed to produce this amount of charge. Okay, so that is question number 2. Okay, now look at question number 3. So question number 3 is, what is the magnitude of the electric force of attraction between an iron nucleus and its innermost electron? Okay, we have iron nucleus. This is a iron nucleus, and inside there you got 26 E. Well, we see the positive 26 E. E normally is a symbol used to represent the charge of an electron. But we know that inside the nucleus we don't have electron, so that positive 26E represent you have 26 proton. Okay, so the charge of proton is the same magnitude as this value, but it is positive, so that's why we have equivalent to positive 26E. Okay, positive, alright? And then the innermost electron, because you have 26 proton, you're supposed to have 26 electron circulating around a neutral ion atom. But we are only asked for the innermost, one of the nearest electron to the nucleus. So this is nucleus. You have the first orbit, 2 electron. The next orbit is 8 electron. Next one 8 again. Okay, and extend to further orbit. So we only look at one of these electron, okay, which is at a distance r of equal to 1.5 10 to the power negative 12 meter. So because this is positive, this is negative, so the electron actually is being attracted to the nucleus. So we are going to find the force. Okay, so I believe it's only the magnitude of the force. Again, direction is not needed. Of course, direction is towards the nucleus. So the force will be, first we calculate the magnitude only. So the force is K Q1 Q2 over R squared. Q1 I will refer to the total charge of a nucleus, and the Q2 is the charge of the electron, and the distance is this one, 1.5 10 to the power minus 12 meter. Okay, so we have the K value times the charge. You have 26, right? 26 electron, and then multiply by the charge of 1 electron. Okay, and you're gonna have this 1.5 10 to the power negative 12, and don't forget the square. Okay, so our value for this is 8.99 10 to the power 9, 26, and then you have 2 electrons. Okay, but you have 1 negative here. Don't worry about that, because after we take magnitude, the negative sign disappears. So now we have E square, right? You have E square, and then divide by this 1.5 10 to the power negative 12 square. Okay, our electron value is equivalent to this value. Okay, so we're going to square that later. So now we calculate 8.99 10 to the power 9 multiplied by 26 multiplied by the charge of electron, 602 minus 19 square. Okay, and then divide by 1.5 10 to the power minus 12 square, and this is what we get. Okay, so we have 2.67 10 to the power minus 3 Newton. Okay, so let me check again the answer. 8.99 10 to the power 9 multiply 26, and then multiply by the charge of electron, minus 19 square, and then divide by the distance, minus 12 square. Okay, correct. So it's 2.67 10 to the power minus 3. Alright, so that is the first 3 question. Okay, next one, question number 4. Okay, question 4. What is a repulsive electrical force between 2 protons in a nucleus that are 5 10 to the power minus 15 meter apart from each other? 2 protons so near. Okay, you have 1 proton here at a distance r, another proton here. Remember, the proton is a positive 1.602 power minus 19. So their charges are the same. So I'll call this one Q1, 1.602 minus 19 coulomb. Q2 also the same, positive 10 to the power minus 19 coulomb. The distance r is 5 5.0 10 to the power minus 15 meter. Very close. That's a nuclear scale already. Okay. So same formula, we know that they're going to repel each other. Okay. The repulsive force I'll call F. But we need to calculate for one only because the next one is the same. So the formula for the force is Q1 Q2 over R squared. Right? Since the charges are the same, we'll just square them. Square, both the same, right? And then divide by distance 5.0 10 to the power minus 15 negative, and don't forget to square, and that's the answer. Okay, so power 9 times 1.602 minus 19 square, and divide by 5 10 to the power minus 15 square. Okay, the force is 9.23 Newton. Okay, 9.23 Newton. Right? Okay, so that is question number 4. Next one. Question number 5. Okay, question number 5. Okay, what is the magnitude of the force a positive 25 microcoulomb charge exert on a 3 millicoulomb charge 35 cm away? Okay, our first charge is called Q1, 25 microcoulomb positive, and then at the distance away we have another charge which is also positive. I call this Q2, and it is 3.0 millicoulomb. Okay, millicoulomb, and at the distance of 35 centimeter. Okay, 35 centimeter. So we know both are positive, so they'll be repelling each other. Okay, on both sides. Okay, so there's a force F. So we calculate the force. Okay, Q1 Q2 over R squared. Okay, and this one is 25 micro minus 6, and milli is 10 to the power minus 3. And the distance, 35 cm, change to meter, 0.35 meter square. Alright? Okay. 3 minus 3 multiplied by 25 power negative 6, and then multiply at 0.99, 10 to the power 9, and then divide 0.35 squared. Okay, we have this answer, 5504. Okay, 5504 Newton. Alright, so far these are easy question. Okay, if you look at the bracket after the question is 1, those are easy question. Okay, and then we go to the more difficult question which has category 2. Okay, so look for the second video. Thank you.